So, hi everyone, my name is Sagar and I'm an Android engineer at Via Europe. Today I'll be showing you the implementation and the automation journey of one of my open source project where I'm implementing baseline profile. It's a project named Play Info, and it basically you can track which games you have played so far or have lent to someone. So it's more of a way for you to manage your games, like put a status on them. And yeah, that's mainly it. And I have implemented baseline profile into it and like automating. So I'll be sharing the journey of what I've been through so far. So when I started implementing baseline profile, before that, how I came to know about this is that there was a huge problem. Before this, by Europe, I was working at Get Your Guide, and we had there was a specific big component which is a date picker, and this is entirely built in lazy list and in compose. And as you can see, it's like quite stuttery and the quite janky UI. And it's not even just the visual, even the logs were screaming, choreographer saying, hey, this many frames had been skipped and this and that. So that was very painful. Nobody wanted to touch it. It was such a big component. So I started researching what I can do. Oops. And I've came up with two solutions. One of is actually to refactor the composables and to stabilize them so that they can avoid recompositions. That was the hard one actually. So one has to review the entire PR and I have to dig into the entire code base. So I started with actually implementing the baseline profiles. With this, I didn't have to touch the code, and I still get a better runtime performance. So this was really helpful. And I already have few articles on them on mastering Jetpack Compose, where I've covered different phases of Jetpack Compose and how to stabilize them, and similar on the baseline profile as well. Before proceeding forward, how many here of you guys are already using baseline profile into their production project? Like maybe raise hands if you are. Okay, not many. Okay, so that's good. Okay. So today I'll be showing you first how the code execution history in the Android have evolved over the years, and how we came to baseline profile, and we will see what is baseline profile, its implementation, what are the results we get, how to measure the results, and how can we automate it on our CI so that we don't have to do this every time. So starting with code execution history, we have three dimensions: Android, approach, and the problem. So we'll look at what happened in each Android version. So with Android 1, your code is being interpreted only. So it starts with the interpreted mode, and the eventual performance is also in interpreter mode. Because performance was quite slow, at that time there was no optimizations being saved at the time, because storage was also quite small. So that was in the Android 1, but with Android Froyo, just in compiler significantly improved the app performance. Building on previously built interpreted approach only, this improved the entire apps ecosystem performance, and nobody has to do anything. So it was a very nice change. Everybody welcomes. You don't have to do anything. You get a faster performance. Why not? Initially, so how it works, code starts in the interpreter mode and the app runs just-in-time compiler as the code executed frequently. So once the classes and methods is being deemed hot, just-in-time compiler optimize that code further, leading to a faster performance. And since the problem with this approach is that still your core app is being started in the interpreter mode, still the startup is slow and the optimizations were not saved. When the process is destroyed, these optimizations are discarded, again due to storage limitations. But with Android 5.0, they introduced a full ahead of time compilation. Now what's that? Let's take a look. This is a screenshot from one of the Google talk, where what happens is when you install the app, new compiler is being introduced, that is Dex2O. Dex2O essentially optimized your entire app, entire Dex code into a ODEX file. So next time when your app starts, it starts into the optimized Dex file. So your entire app is being optimized and it will use this optimized code to run the app. And if you guys all remember, like we had this dialogue back then, because whenever you do the system update, all the apps needs to get optimized again. And considering like this is running on a very resource constrained device, and this is why the reason usually whenever this pop-up comes up, the device gets very hot, right? And it takes a lot of time actually to also optimize all the apps. So still we have few problems where the DEX2 compiler were taking too long, and since we are storing all these optimizations on the storage, it was very storage intensive. So next, in Android 7, the profile guided optimizations was being introduced. So, and Android took a hybrid approach where instead of optimizing the entire app, it was a bit of a mixed approach. So when the app starts, it starts in the interpreter mode, and then after that, just-in-time compiler kicks in. As you go through the app, the journeys are being saved into a file called profile, which is into its specific app package directory. And then when your device is idle, all these optimizations is being converted into machine code using DEX2 And when you start the app next time, you have a mix of both optimized code and the DEX code. So, but still, you are stuck with the mix of slow start and fast start. When your app starts, you're still in the interpreter mode, and then just time compiler kicks in. We want like a good performance right from the start. Still, this is not being fulfilled, right? So later on, with Android 9.0, cloud profiles was introduced. Now, since you are saying like in 7.0, we are already saving some optimizations, right? And Android thought, okay, why not we can take advantage of it and crowdsource this profile. And once we aggregate all of these profiles together, and we will ship it with a Google Play bundle. So when you install the app, you get these optimizations. But even though you get these optimizations, still there is a big caveat in it. It will take a while for Google Play to provide these profiles, because let's say your app has not many users, your profile might not be generated at all in that life cycle, or maybe before your next release. So that was a big issue. Also, like if you are on a weekly release, and if you don't have that many users, by the time you are introducing a new release, there might be no optimizations available. So still there is a certain set of cohort, even if you have like a lot of users, still there's a certain set of starting users who will never get these optimizations. So then the introduction of baseline profile. What are baseline profile? So it's just a list of classes and method for the compiler to understand to optimize this. So why it's important? So that you get faster performance and you can include it in your app. And so you can define what's important for your app. And it's for apps and libraries both. Since I guess most people nowadays use Jetpack Compose, and Jetpack Compose is an unbundled library. It doesn't get benefit from the Zygote. And since even Jetpack Compose comes with the baseline profile, because it needs to optimize the code. Now, that's how baseline profile output looks like. It has certain characteristics, like each rule is one per line, and each rule has three things essentially: a flag, a class, and a descriptor. Flag, class, and the method signature. And each flag, if you see, there is H, there is S, and P. H means hot. That means this code is being executed very frequently. So Android needs to have this while initiating the application process. S means startup, that we need this code during the startup time. P means post startup, we need this after the post startup. And if you will right now, if you are using Jetpack Compose, maybe some other library who is already using baseline profile, if you'll check your application under the DEX2 you will see a baseline profile file. And you will see there are 9,000 rules already, but you might be wondering why there is baseline profile. I haven't added anything into my app yet, still there is baseline profile. As I said earlier, Jetpack Compose comes with a baseline profile. So how it works is that AGP picks up all the baseline profile like the manifest merger works. It picks up all the manifest and then merges into one. Similar thing happens with the baseline profile. That's why we have one. But then we actually add baseline profile to your app. There is now, if you see, 12,000 rules. So there is addition of rules that you have added. So now let's see how we can generate the baseline profiles. There is a very nice wizard that you can use to generate the baseline profile. So you can use this wizard. It will generate a lot of goop for you, and then you have to actually tweak the things according to your project. So this is how essentially it will look like. It will create a specific new module for you. I have created a benchmark module. So I have baseline profile directory in which I keep the baseline profile generators. So there might be multiple generators. There might be one for the sign up flow. There might be one for the home flow. And there might be one from where you click on the notification and open the app, because these are the most common entry points to your app. And then we have the benchmark directory in which we are checking what are the results and comparing how it's doing. We will come back to it later on. So this is how our scaffold class looks like. It's just a class where you hold all the same configuration into the app. So we have this rule, which is baseline profile rule. You specify the target package directory, and then inside the profile block, you define all the interaction, maybe using UI automator, right? And if you're seeing this include in startup profile, forget about this. We will come to this later on. Now we have this generator class which extends the scaffold, and inside this we have this profile block where we are defining the interactions that app needs to do. If you say start, activity, and wait, this is essentially saying start the app and wait until the first pixel is drawn. And then we are doing our own interaction, maybe start until this. So we are now essentially optimizing the sign up flow. That's why it says like start up until sign up flow. Let's take a look what's inside this method. Now, if you'll see, we are essentially saying, hey, click on this button, like just navigate through the app, enter the name inside here, and make sure that the submit button is there. Now we have the generator ready, everything. Now let's generate the baseline profile. So you can generate baseline. We are generating baseline profile specifically for the release app, and with this command generate release baseline profile, we are adding a specific flag that is enable rules for baseline profile. What it does essentially, it only runs the test for the baseline profile generator and not for the benchmark. If you run without this flag, it will run the test for the benchmark as well. So yeah. Let's see. So this is how it looks like when you run the baseline profile. It just keep iterates through the same thing, and essentially it gathers all the traces and pull it from using ADB commands internally. So macro benchmark essentially doing all the hard work for you. It essentially pulled all the profile into your Android Studio right next to the baseline profile directory where you need it. So yeah. It will keep doing it until the profile is stable. Now let's move forward. So once this is done, we are saving this inside this baseline profile directory, and this is how it looks like. Usually it comes under the release variant, but we are having this under the main baseline profile because I have a specific build.gradle configuration to save it inside it so that all the variants can get benefit from this baseline profile. Now, yeah. But wait, there is more. There are startup profiles as well. Since you have done already all of this work, right? What is startup profile? It is DEX layout optimization. Now it might be like 2-3 words. What does it mean? Essentially, R8 will break down your one class.dex into 2, so that all the code that is related to the startup will be executed, so that it can aggressively load the startup first and then use the other DEX for post startup work. And with this, like with startup profiles, you might get 15% more startup better than your alone baseline profiles. So in order to enable the DEX layout optimization, you need to enable this flag, which is DEX layout optimization, which is true. We are doing it for the release build, and you have to also pass true, right? Include in startup profile. You have to pass this flag to true. So now in order to generate the startup profiles as well, just run your baseline profiles, and in your baseline profile directory now you will see two text files. One is baseline profile and second is the startup profiles. Now again another comparison, if your app only have baseline profiles, right, you only have one dex file. If you'll see on the top there is only one classes.dex, and right now the rules are 12,000 rules of. And with startup profiles, there are two dex files, because one of the dex files will be used for the startup to aggressively load the startup so that we have like faster startup performance. And now the rules are even increased, which is like almost 14,000. But you'll say, how fast my app will become, like faster, like how fast, like exactly, tell me the metrics. So most of my work on the baseline profile is being done at Getter Guide, and there we have saw startup improvement by 20% and runtime performance by more than 25%. Now, how can we measure this? We can measure this like we have three ways: macro benchmarking, Firebase performance, and Android vitals. Now with macro benchmarking, we can do the local benchmarking, and then we get metrics like time to initial display, time to full display, frame overruns, frame duration, and traces. We will see what these metrics are. So before, let's see how to generate it. It's the same macro benchmark test, but with a different kind of rule. So you can do this rule, which is rule.measure repeated, and then inside you can define what's the startup mode. So we're starting the app right from the cold startup, and we are saying 15 iterations, because if you do two less iterations, like it might generate some not that stable metrics. So we are reusing the same UI automation interactions here as well. Now you can generate the benchmarks using this command, which is connected benchmark release Android test. Release is the build variant. So what are the results? That's how the results will look like. So we have different metrics, right? In the results, if you'll see, the runtime performance is improved by almost 80%. And you can see that the frame overruns for the baseline profile is 2.8 for the P90. And for the startup compilation, it's 4.0. So you have this formula, you can calculate it, it's 80%. But why our startup is 20% like slow, like what's going on? Like it's supposed to increase the startup increase the startup performance. What happens is that I had this question by myself, so I started investigating what's going on wrong. So I got the answer from the developer advocate who is on the baseline profile and performance, Ben Weiss. You can check the discussion under this GitHub discussion. There are a handful of factors, like there might be a reason that the device on which I was doing the benchmarking might be doing some extra work in the background. So that could have led to unstable metrics. But if you can see, we have above, the traces is being pulled into the Perfetto, and you see there is a just-in-time thread pool, and then there is just-in-time thread pool here as well. In the compilation.none, there is more crowded work happening. If you'll see, there is a lot of purple and green lines, and in the baseline profile, there is just like almost all clean. So that means that just-in-time compiler is doing less work with baseline profiles, because we are already shipping baseline profiles with it. Now, if you say, hey, local benchmarking metrics, all good, but give me the production metrics. You can get production metrics for your specific component in Firebase as well, where you get percentage of slow frames and frozen frames. The specific component, when we started, right, the date picker component, for that we decreased almost 60% of frozen frames with baseline profiles, and we measure it through as well Firebase performance. And in the Android vitals as well, which is also production metrics, you get percentage of slow, cold, warm, and hot startups. So you get these metrics as well. So you don't have to do anything. You just go into your Play console, find the Android vitals, and you get these metrics. And now how to automate it, because so ideally, if you'll be asking how many times I have to generate the baseline profile, essentially like whenever your code changes. So let's see how we can automate on the CI. So there are multiple ways to automate it. So we are using Gradle managed device, which is a headless simulator to run, and we are running it on GitHub Actions. And you can do it on a Firebase test lab as well. But for this example, we're doing it on a GitHub Actions, and I have specifically enabled this flag, which is automatic generation during build to true. What essentially has happened, whenever we assemble the release build, it will first generate the baseline profile, and then it will assemble the release build. So AGP will automatically pick up the freshly generated baseline profiles. So, but it's not that easy exactly. There is a huge long issue related generating the baseline profiles on the GitHub Actions. So you need some extra flags. You need to enable the KVM if you are using the Ubuntu machine on the GitHub Actions, especially when you're on the free tier. There might be some few flakiness, but you need to add these flags, which is use the software rendering instead of the GPU rendering, and then you need to max concurrent devices to 1, and maybe increase the timer, because now that you are only using one device, increase the timer. You can avoid using the kernel logging to true, but I just keep it for debugging purpose. So as you can see now on the CI, we have the baseline profile ready, generated. It generated the baseline profile as well and the startup profile. Nice work. Now some common questions. Should I add baseline profile for my entire app? Please don't do it, because it will generate the big profile, and essentially then it will cause more time to load the profile in the startup. Hence again, you have a slower startup time. So please don't do it. And should every app needs baseline profile? I would say yes. If you love your users and you want like a faster performance for your app, and if you have seen like the complexity of the Android code over the years has been increased significantly as compared to the Android hardware, right? And or the Android runtime performance. It's just barely catching up. That's why we need a baseline profile into our apps, like a way for us to provide the optimized code for the critical user journeys. Now, should I cover onboarding login journeys as well? I would say yes, because that was the key consideration. When in Getter Guide, we were optimizing this. Most people just use the app once and then they might delete the app. So high performance right from the first install time is very important. And does baseline profile works on platforms other than Play Store? Yes, because profile installer API will help you, and it's already in the baseline profile wizard group. So yeah, thank you. That's my Twitter if you want to ask me anything, and yeah, if you have any questions.